From Vandenberg Air Force Base in California, ULA presents live Atlas V launch coverage. At Space Launch Complex 3, an Atlas V rocket is fueled and ready to launch the NROL-55 mission for the National Reconnaissance Office.
Range, go for launch. Roger, go for launch.
Three, two, one.
Atlas engine ignition.
Liftoff of the United Launch Alliance Delta IV Heavy rocket.
Good morning and welcome to Vandenberg Air Force Base. I'm Matt Donovan and I'll be your commentator for this morning's launch. We are currently on track for our 5:49:30 a.m. Pacific Time liftoff this morning. The team is currently in the T-4 hold and not working any issues at this time. This planned 30-minute hold gives the team time to conduct any final system checks and also resolve any outstanding issues prior to entering the terminal count. At the request of our customer, this morning's live mission coverage will conclude following confirmation of payload fairing jettison, which is scheduled to occur approximately 4.5 minutes after liftoff. However, before we sign off, I will be joined by NASA's Andres Martinez to discuss OCSD, one of the 13 CubeSats launching today. I'll tell you a little bit more about that later in the show. We recently received a final weather briefing from the 30th Space Wing's weather officer. The weather is within the launch commit criteria for this morning's liftoff. Our probability of violating launch constraints is 0%. The ground winds are 5 to 8 knots out of the east-northeast, and the temperature this morning is 57 degrees Fahrenheit. So the weather looks great for a launch this morning, and we're proceeding towards liftoff with a planned T0 of 5:49:30 Pacific Time. This is Atlas Mission Control at T-4 minutes and holding. While final preparations for launch continue, here's a preview of what you'll see today.
The following profile details the important events of this mission using approximate time.
4, 3, 2, we have ignition and we have liftoff of the United Launch Alliance.
The Atlas RD-180 main engine ignites to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The vehicle reaches Mach 1, the speed of sound, at 81 seconds. At 89 seconds, the vehicle experiences maximum dynamic pressure. Approaching booster engine cutoff, the Atlas V booster is burning propellant at the rate of more than 1,720 pounds per second at an altitude of more than 63 nautical miles and a distance of 134 nautical miles downrange, and traveling at a speed of more than 8,220 miles per hour. Booster engine cutoff occurs approximately 4 minutes after liftoff. 6 seconds after booster engine cutoff, the booster stage is jettisoned. The first Centaur main engine start takes place 10 seconds after booster separation. The payload fairing is jettisoned at 4 minutes, 25 seconds.
ULA is using the Atlas V 401 configuration to launch the NRO-L-55 mission. This is the 58th Atlas V launch since the inaugural flight in 2002 and the 101st ULA mission since company formation in 2006. This morning's launch countdown began just after midnight with the rollback of the Mobile Service Tower, or MST. We'll see that coming up, but first I had the opportunity to tour the launch pad before the roll. Let's have a look, starting with final vehicle preparations that took place at the pad a few weeks back. On September 16th, the encapsulated payload fairing was before launch preparations began. Final preparations for launch take place in the 260-foot-tall Mobile Service Tower, which is currently in the service position. Weighing in at nearly 11 million pounds, the MST provides access to the launch vehicle and payload, as well as protection from the weather. The Atlas V launch vehicle is produced in Decatur, Alabama. It is comprised of a common core booster powered by the NPO Energomash RD-180 main engine. The Centaur upper stage is powered by the Aerojet Rocketdyne RL-10C engine. The NROL-55 payload is protected during ascent by the 4-meter diameter payload fairing. The payload fairing is manufactured at ULA's Harlingen, Texas facility. After years of hard work and preparation, we're just hours away from roll of the Mobile Service Tower here at Space Launch Complex 3. The MST is moved about 250 feet southeast of the launch vehicle, a trip that takes approximately 20 minutes to complete. The Atlas V stands 188 feet tall, or about 19 stories, and fully fueled it weighs about 750,000 pounds. To lift the Atlas V away from the pad, the RD-180 engine produces more than 860,000 pounds of thrust. With the MST rolled back in the park position, the launch pad team completes its final task for launch before exiting the pad. Once the pad has been cleared, the Atlas V is fueled and configured for launch.
LC, this is RFFTS.
Go ahead.
Davis System Cabras, figured for launch.
Roger.
This is Atlas Mission Control at T-minus 4 minutes and holding. This morning's flight will deliver the NRO-L-55 payload to orbit. The NRO is a joint organization engaged in the research and development, acquisition, launch, and operation of innovative overhead reconnaissance systems necessary to meet the needs of the intelligence community and the Department of Defense. The NRO is recognized for its transformational intelligence collection systems that are used to develop highly accurate military targeting data, support international peacekeeping and humanitarian relief operations, and to assess the impact of natural disasters. As I mentioned earlier, in addition to the NRO-L-55 payload, we've partnered with the National Reconnaissance Office to utilize the Aft Bulkhead Carrier, or ABC, to deliver smaller auxiliary CubeSats to orbit. Capitalizing on the performance of the Atlas V vehicle, the ABC carrying the GRACE payload is mounted on the Centaur. GRACE, which is short for Government Rideshare Advanced Concepts Experiment, consists of 13 CubeSats developed under the sponsorship of the NRO and NASA. This innovative program enables hands-on experiences, proof of concept demonstrations, and increases the readiness level of emerging technologies. The 9 NRO-sponsored CubeSats were developed by the Aerospace Corporation, the Army Space and Missile Center, TIVAC, and SRI International. The 4 NASA-sponsored CubeSats were developed by the University of Alaska Fairbanks, Salish Kootenai College, AMSAT, and the Jet Propulsion Laboratory. Collectively, these CubeSats will demonstrate tracking technologies, test optical, laser, and radio communications, perform dual-frequency ionospheric calibration measurements, conduct a MEMS gyro and low-energy proton experiment, measure the thermal and vibration environment during launch, and demonstrate a low-mass radio transponder in orbit. In addition, another CubeSat will train students on the design, build, test, This is Atlas Mission Control at T-minus 4 minutes and holding. For most missions, our customers provide artwork which is added to the payload fairing. In this case, hand-painted at our Harlingen, Texas facility. For NROL-55, the artwork depicts Vulcan, Roman god of the forge. Vulcan is extremely strong, clever, and hard-working. The sweat on his brow and intense focus on the task emphasizes work ethic. His forged weapons and armor supported the warfighters of mythology. If you look closely, you'll find the phrase Sustente Spellatores Decalis, which translates as supporting the warrior from space.
Redline monitor and the event table are in the correct configuration for terminal count.
Roger. Perform launch on time verification.
Roger.
Verify solar radiation acceptable for launch.
Launch on time verified.
Roger.
Verified.
Com check and countdown 1. STC.
Loud and clear.
TC1.
Loud and clear.
TC2.
Loud and clear.
LC switch to the ready position. All steps are complete prior to the status check.
This is Atlas Mission Control at T-minus 4 minutes and holding. We remain in the planned 30-minute built-in hold as preparations for the launch continue. In a few moments, launch conductor Mark Levesque will pull the launch team for the final go to pick up the countdown. 27 engineers and managers will be pulled for system status and readiness to proceed with the launch. This is the final status check before launch for all Atlas vehicle systems, ground systems, payload, and the U.S. Air Force Western Range. The readiness poll includes hydraulics, pad water deluge system, electrical systems, pneumatics, propulsion systems, flight control, and propellants. Let's listen as Mark Levesque performs the final polling of the launch team.
Status check to proceed with terminal count. Atlas systems. Propulsion. Go. Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems. Propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
HASGAS.
Go.
Electrical systems. Airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
Instrumentation.
Go.
COM.
Go.
Timer. Go. GC cube.
Go.
Umbilicals. Go. ECS. Go. Facilities.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
Relay safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Cleared to proceed.
Launch director.
Launch vehicle is ready to launch.
Mission director.
You have permission to launch.
Proceeding with the count. T0 is planned for 12:49:30 Zulu. Set count to start at 12:45:30 Zulu.
Roger. T0 is set for...
Polling is complete and the launch team has given the go for launch. The countdown will resume approximately 2 minutes from now. From T-minus 4 minutes until launch, you will be listening to launch conductor Mark Levesque and his team performing the final steps in the countdown procedure. At T-minus 3 minutes, the team will secure Atlas LO2 topping. At T-minus 2 minutes, the team will transfer the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur LH2 and LO2 topping activity. At T-minus 1 minute 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. At T-minus 40 seconds, the Atlas tanks will be verified at flight pressures, followed by verification of the Centaur tank pressures at T-minus 30 seconds. A final status check of Atlas, Centaur, and NROL-55 readiness is conducted at T-minus 25 seconds. At T-minus 3 seconds, the RD-180 main engine will roar to life. Later in this broadcast, you'll hear the voice of Rob Gannon as he provides launch vehicle ascent data. This is Atlas Mission Control at T-minus 4 minutes in holding. We anticipate releasing the hold in just a few moments.
On my mark, the time will be T-minus 4 minutes and counting. 3, 2, 1, mark. .355.
The countdown clock has resumed and we are go for launch.
Three minutes.
Securing LO2 topping.
Atlas tanks to flight pressure.
250.
FTS internal.
.159.
Vehicle internal.
155.
Launch sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
140.
Launch enabled.
137.
FTS armed.
T-minus 90 seconds. The launch vehicle, payload, ground systems, and western range are go for launch.
Orca's armed.
FCS count start.
115. 110.
Vent valves locked.
T-minus 1 minute.
Rock, report range status.
Rock, range is green.
Roger.
.40.
Stable at step 3.
T-minus 30 seconds.
28. 25.
Status check.
Go Atlas. Go Centaur.
Go L55.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. We have RD-180 ignition. And we have liftoff of the United Launch Alliance Atlas V rocket carrying the NRO-L-55 mission for the National Reconnaissance Office.
We have booster PU to close loop control.
You're hearing the voice of Rob Gannon providing launch vehicle ascent
Everything
data.
looking good. The RMR valve position looks good. MTU shaft speed looks good. Flight control is nice and clean, seeing normal disturbances for this time of flight. Main engine continues to operate normally. Vehicle is now flying at half the speed of sound. We are 3 miles in altitude, 0.3 miles downrange, traveling just over 1,000 miles per hour. RD-180 continues to burn normally. Up on Mach 1. L-55 is now supersonic. Flight control continues to be nice and smooth. RD-180 operating normally. We have throttled down to 95%, right on time. Nice and smooth. Two minutes into the mission, everything looking good. Started Q alpha limited steering. RD-180 is burning normal. And the vehicle now weighs 50% of what it did at liftoff. 22 miles in altitude, 20 miles downrange, traveling at 3,000 miles per hour. Just continue to burn normally. And we fired the pyro valve, pressurizing the second stage reaction control system. Pressure is rising as expected. Next event we're looking for, throttling down to 92% thrust. Expect that in 10 seconds. And we've got the throttle down, engine continues to burn normally. Parameters look good. Passing through 200 seconds in the mission, everything looking good. Vehicle now weighs 1/4 of what it did at liftoff. 52 miles in altitude, 107 miles downrange, traveling at 7,800 miles per hour. And we've begun boost phase chill down. Preparing the RL-10 for main engine burn on the second stage. RD-180 is throttling down. Preparation for BECO. Boost phase chill down has completed. BECO, booster engine cutoff. Coming up on stage separation. And we have stage separation. Looking good. Pre-start on fuel, pre-start on locks. Ignition, full thrust. The RL-10 is up and running normally. Good start signatures. Coming up on fairing jettison. And we have fairing jettison. Both brake wires indicate a good jettison.
This is Atlas Mission Control at T+4 minutes, 37 seconds. We've just seen the successful liftoff of the ULA Atlas V carrying the NRO L-55 mission for the National Reconnaissance Office. As I mentioned earlier, today's mission is also carrying 13 CubeSats sponsored by the NRO as well as NASA. And I'm pleased now to be joined by Andres Martinez, the Deputy Program Manager for Small Satellite Technology for NASA. Andres, thanks so much for joining us this morning.
Thanks, Matt. That was a great launch, and I'm very excited. The optical communication and sensor demonstration, also known as OCSD at NASA, is the first of 6 missions for our program. And in the next 9 months, and today was a great start. OCSD will be demonstrating for the first time on a small satellite laser communication.
That's really exciting to hear about the kind of capabilities that we're able to take to orbit with these CubeSats. So why is NASA so interested in these kinds of technologies and small sats, CubeSats?
Small satellites provide NASA the ability to rapidly develop and launch groundbreaking technologies into space. At NASA, we have also been using small satellites to conduct fundamental space biology for over a decade now.
It's amazing what you can do with a small satellite. So this is actually the first of 2 that are currently in the plans. Why is this mission so important to NASA to demonstrate this optical communication and sensor capability?
Yes, this is the first of 2 OCSD missions. The second one will be in about 4 months. Laser communication will provide small satellites a capability of significantly increasing the amount of data we can download from space in a very short period of time. For example, during my last space mission, it took us over 100 days to download just half a megabyte. OCSD will accomplish that within seconds.
It's amazing the leap forward in technology. So tell me a little bit more about how the spacecraft is going to be able to interact with the ground station.
Sure. We have a ground station on Mount Wilson near Pasadena, California. OCSD will be using its very sophisticated attitude control system to align itself with high precision as it passes over Mount Wilson and its ground station. And it's going to beam a laser from 600 to 700 kilometers up in space, and it will hit a target that's only 30 centimeters wide. That's pretty incredible.
That is amazing. So how will this kind of technology enable future exploration with NASA?
Laser communication is being investigated to also support deep space missions like Mars, for example. OCSD demonstrations will provide quite a bit of data so that the technology can continue to be matured.
So these tiny spacecraft demonstrations, what do you see as the future going forward for this kind of capability?
You know, the small satellite technology capability has been leapfrogging. It's moving very rapidly, and you know, it's gotten the attention of NASA and other agencies and the commercial industry. In the future, we see swarms of satellites supporting the bigger missions as scouts, and so you know, for that, we need to continue to advance the technologies.
Well, that's really exciting. Thanks so much for joining me this morning, Andres. I wish you the best of luck with OCSD. We had a great start this morning.
Thank you, Matt. Thank you for inviting me, and I wouldn't be anywhere else. Thanks. This was a great experience.
So at this point, we're going to be concluding our live coverage from this morning's broadcast per our customer's request. I'd like to thank Rob Gannon for providing us with support for this morning's mission and providing us with the launch vehicle ascent data. It's been a really exciting week at ULA. We were able to celebrate our 100th launch last week, and now our opportunity this morning to support our NRO customer. While each launch is a one-at-a-time mission, we've now had the opportunity to do that 100 times consecutively, and we have a little video to share with you about that.
Go hydraulics, go pneumatics.
Get to T-4, which is the critical count. And at that point, your heart starts to race, and you feel a lump rise in your throat, and breathe a little faster. And that happens every time.
It's an amazing feeling. And you just feel kind of overwhelmed, like when they're counting down and when, you're just waiting for it to go, and, it's kind of like you're holding your breath.
And that final 4 minutes of count is unlike anything else in the world. It's your pulse is pounding.
I get butterflies, it's built by hand. It's unbelievable that we do that. And I know my fellow workers here and the pride we take in building these rockets.
Everybody's checking their system. Everybody's checking their data, that everything looks nominal. Once we are ready, hey, we're ready.
On my mark, the time will be T-minus 4 minutes and counting. Mark.
We started back in 2006 with two competitors coming together.
It was kind of a surprise to most of the team. Didn't know how we were going to blend the two heritages, but within a couple weeks we were launching rockets. Our first launch was the NROL-51 from Vandenberg on the Delta II rocket. And here we are, our 100th launch.
100 launches, it's taken a lot of attention to detail. It's taken a lot of hard work, and it's taken a lot of people just doing their job every day.
Our people are very dedicated. They're very experienced. They go above and beyond.
What makes us so successful as a team is that word right there, team. We're a team that work together, mesh together, from the engineers to the assemblers.
Every single mission is critical, and as part of that, every task that we perform every single day has to be done 100% correctly. Has to be right.
Well, a lot of things have to go right in a rocket launch. A lot of things have to go right in your production flow, in your processes to get it on time and on tempo.
It's teamwork, and both Delta and Atlas are working together to make sure that everything's successful.
The ULA team to me is incredible. It is one of the best teams I've ever participated with, been a part of.
Loyalty to ULA and the dedication to the mission success. You can see it in every little detail.
Mission success is not just a program or an individual process. Mission success has become embedded in our culture. It affects everything we do.
Mission success is everything. I mean, that's what we take our most pride on. We have to have mission success.
This is a very demanding business. When I think about the people who are relying on me, the men and women in uniform who are out in the field defending our freedom, I feel a tremendous obligation to them to do the same.
When you actually put your hands on something that, is going to help our world and our military and our government and just everyone in general, you feel an overwhelming feeling of accomplishment.
To me, the missions where we're sending up GPS satellites and supporting the military is the most important thing about this job, and I feel more proud about it than I do anything.
It's a pride in knowing that you're supporting your warfighters, your nation, the world.
All the scientists, the world is counting on us for these scientific missions we launch for NASA.
We have enabled large rovers to land on Mars. We've helped NASA follow the history of water on Mars.
ACs go. Range coordinator. Clear. The launch vehicle is ready to launch. Mission director.
This is the mission director. You have permission to launch.
Proceeding with the count.
Rockets are very unforgiving. You get one chance to get it right. And if it's not 100% right when it leaves the ground, you'll know it in a hurry.
Going through everything in my mind, did I do everything right? Did I do everything to the best of my abilities to make sure we're going to get this exactly where it needs to go?
Perfect.
There's nothing less. You want every system to be perfect.
You cannot do it without the best people in the business, and we've got those.
And as that clock counts down, 5, 4, 3, it's all I can do to stay in my chair. I want to stand up. I want to watch the launch.
4, 3, 2, 0. RD-180 ignition. And liftoff. Liftoff of the 100th United Launch Alliance rocket.
As you can see it go up, but it's 30 seconds or more until you start to feel it. You can feel the power, the controlled explosion.
Well, it's that few seconds of the unknown, but then it's just a beautiful sight.
As it flies up into the sky, and it's just amazing to see the flames hurt your eyes. It's so bright.
It's amazing how loud it is. I had no idea it would be so loud, and it just kind of goes through you. You can feel it in your chest. It's just mind-blowing.
I can't imagine another industry that gives you that type of job satisfaction.
It's very exciting. And to think on top of that is a very special piece of machinery that has a job, has a mission, and we're getting it exactly where it wants to go every single time.
And we have spacecraft separation.
Congratulations to Mexico's Ministry of Communications and Transportation.
100 successful launches. And that says a lot right there about this company. Nobody else has a record like that.
Because we've done it 99 times in a row, and now 100 times in a row. It doesn't mean 101 is going to be any easier. We have to continue to focus on all of those things that it takes to be successful and continue to respect how hard it is to launch and how unforgiving that rocket is.
So to recap, you've seen the successful liftoff of the Atlas V carrying the NROL-55 mission for the National Reconnaissance Office this morning. That occurred at 5:49:30 a.m. Pacific Time. For more information about ULA or the Atlas V, you can visit our website at www.ulalaunch.com or join the conversation on Facebook and Twitter. We'll leave you with one last look at this morning's liftoff. I'm Matt Donovan, and on behalf of the entire launch team, thank you for joining us and have a great day. 7, 6, 5, 4, 3, 2. We have RD-180 ignition, and we have liftoff of the United Launch Alliance Atlas V rocket carrying the NRO-L-55 mission for the National Reconnaissance Office.
We have booster PU to close loop control.
You're hearing the voice of Rob Gannon providing launch vehicle ascent data.
Good.